Hello students, in this video we are going to discuss a very important topic, Fourier transform. In this we are discussing basically a definition and why it is very important, and we are solving some problems. The Fourier transform is a mathematical tool that transforms a waveform into an alternate representation characterized by sine and cosines. The Fourier transform shows that any waveform can be rewritten as sum of sinusoidal function. The Fourier transform is called the frequency domain representation of the original signal. So it mainly uses in electrical engineering for signals. Both Fourier transform and Fourier series are mathematical tools for representing signals in frequency domain, and Fourier transform is an extension of Fourier series. Fourier series is mainly used for periodic signals. Fourier series used for periodic signals. Fourier transforms used for aperiodic signal. Also, a Fourier transform allows us to perform a lot of manipulations like filtering, sampling, modulation, etc. It is used in the study of frequency response of a filter, and we know that Laplace transform will be used to solve the ordinary differential equation. We have done that. Same way, the Fourier transform will be used to find the partial differential equation. So let's begin the discussion formally. What is the definition, mathematical definition of Fourier transform? The Fourier transform, this is also called infinite Fourier transform of a real valued function f of x is defined by f, capital F represent Fourier transform operating on the function that's equal to integral minus infinity to infinity f of x e power iux dx. So this can also be denoted as f of u because on solving this integration we get a function of u. The inverse Fourier transform is defined by, so when you are operating Fourier transform on the function x, we expect the function of u. Now inverse Fourier transform operating on u term, so that is inverse on f of u, or you can write f inverse like this, f bar of u. The definition is 1 by 2 pi integral minus infinity to infinity, that f of u what we have e power minus iux with respect to du. So that can be written as, so what we expect, function of x, reverse process. Okay. So in operating Fourier transform, we are integrating with respect to x and we are taking e power plus. On operating inverse Fourier transform, we are taking 1 by 2 pi outside. Here operating on f of u e power minus and integrating with respect to u. So let's start solving problem. We have here very important problem for exams also. So find the complex Fourier transform. So Fourier transform is also called as complex Fourier transform or infinite Fourier transform of the function f of x given by the function 1 for modulus of x less than or equal to a and 0 for modulus of x greater than a. Hence evaluate integral 0 to infinity sin x by x. So first let us obtain the Fourier transform of this type of function. Firstly, the interval format, it is given as modulus of x. So when the modulus of x less than or equal to a, nothing but x lies between minus a to plus a. So therefore, so first I am obtaining Fourier transform of function. I'll write the formula is what, integral minus infinity to infinity on which function f of x e power iux dx. Now I'll write this as f of u and I'll substitute for the function given. When I'm substituting the function, I'll observe the given function is defined 1 for the range minus a to a. remaining all 0. Therefore, I consider the same interval given. It is integral minus a to a and function is 1 e power iux dx. So, we have very simple integration. Integration of e power iux with respect to x, e power iux by iu, and apply the limit minus a to plus a. Next, we apply the limit. I'll take 1 by iu out, applying upper limit e power iua, and when I'm applying lower limit minus, I'll take e power minus iua. Next, I simplify this as 1 by iu. E power iua can be written as cos au plus I sin au minus e power minus iu can be written as cos au minus I sin au. So here cos au minus cos au gets cancelled. We get what? It is 1 by iu. So what is remaining? It's a 2 times I sin au. Okay, now I gets cancelled. So our answer become 2 sin au by u. This is our required Fourier transform. Now the question is what? Obtain the Fourier transform of the function, that is we have done. Now we have to evaluate the result integral 0 to infinity sin x by x is what? So when you are evaluating the result extra like this, we have to use inverse Fourier transform. To evaluate integral 0 to infinity sin x by x dx, we use inverse Fourier transform, that is f of x is equal to inverse Fourier transform of f of u, that is 1 by 2 pi integral minus infinity to infinity f of u e power minus iux du. So substituting now for f of u, while you are proving some result, you should not integrate this part. We have to just simplify under the integration part. So where f of u is what? 2 sin au divided by u, and we keep e power minus iux du. So because we want the integral form of the result only, we keep the integration as it is. Now we want integral sin x by x only. So keeping sin term as it is with divide by u, keep in the mind u as x. Then we have to eliminate this e power minus iux. To eliminate that, we have to put x is equal to 0. Throughout the equation, we have to put x is equal to 0. So then f of 0 is equal to 1 by 2 pi integral minus infinity to infinity 2 sin au by u du. E power 0 become 1. So what is f of 0? We know that our function f of x is 1 for x less than or equal to a, 0 for x greater than a. So 0 lies in the range modulus of x less than or equal to a. So for x equal to 0, the function is 1 only. So we substitute that function f of 0 is 1. So therefore substituting f of 0 is 1. So we get 1 by 2 pi. This 2 gets cancelled. 1 by pi, this 2 gets cancelled. Integral minus infinity to infinity sin au by u du. Also, we want the result integral 0 to infinity, and it becomes 0 to infinity when the function is even function. So when you replace u to minus u, we get minus sine au, so that it is even function. Therefore, you can write this as 1 is equal to 2 by pi integral 0 to infinity sine au by u du. So and let us fix. We take au is equal to t or x, go back x. Then from this you can write a du is equal to dx by a. So therefore, when cross multiply here, we get pi by 2 is equal to integral 0 to infinity sine x, when you substitute au is x and u is x by a and du is dx by a. Then this a gets cancelled. We get our solution as integral 0 to infinity sine x by x is dx is with pi by 2. This is the standard result to remember. Let's solve another important problem. We have here f of x is 1 minus x square for modulus of x less than or equal to 1, 0 for modulus of x greater than 1. Find the Fourier transform of this f of x and hence find the value of integral 0 to infinity x cos x minus sin x divided by x cube. So first we write the formula. Fourier transform of f of x can be written as f of u integral minus infinity to infinity f of x e power iux dx. And let's substitute, and we observe the function given 1 minus x square for modulus of x less than or equal to 1. Means we have modulus of x less than or equal to 1, nothing but minus 1 less than or equal to x less than or equal to 1. So we'll take it is minus 1 to 1, where f of x is 1 minus x square e power iux dx. Now let us integrate this by Bernoulli's rule of integration, taking 1 minus x square is first function, e power iux is the second function. Okay, we start integration. So keeping 1 minus x square as it is, first function, integration of e power iux is e power iux by iu, then minus differentiation of 1 minus x square minus 2x, and integration of e power iux by I square u square. Next plus minus 2 integration of e power iux divided by I cube u cube. For this apply the limit minus 1 to 1. Next we apply the limit. Applying upper limit, it gives us 0 in the initial. So when you substitute x is 1 here, it becomes 0. And we have here minus this because I square is minus 1. This minus gets cancelled. Okay. And this I cube can be written as minus I. So there also minus gets cancelled. We have it's finally I into u cube. This can be written as I u cube. So we write the result. It is applying upper limit minus 2 e power iu by u square. Applying upper limit to the second term. Next we have plus 2 by iu cube e power iu. Next applying lower limit, again this becomes 0 because x is minus 1 whole square, it become 1 minus 1 only. So we leave this. Applying lower limit, this minus become plus. So plus 2 into minus 1 minus 2 e power minus iu by u square. And applying lower limit to the last term, minus 2 e power minus iu divided by iu cube. Then we make the group So we take these are one group. So that is minus 2 by u cube common, u square common out. We get e power iu plus e power minus iu. Next, taking plus 2 by iu cube, remain the remaining terms common out, e power iu minus e power minus iu. And this here, if you multiply 2, divide by 2, and for this if you multiply 2i and divide by 2i, you can express this in standard form. So we get this minus 4 by u square cos u plus 4, and this I gets cancelled, can 4 by u cube sin u. So from these two terms you could take 4 by u cube common out, or you can take minus 4 by u cube because we want cos term first. Cos u and u cube term common out, you have to write u minus sin u. So this is our f of u, Fourier transform of the given function. Now to prove the required result, we use the inverse Fourier transform. So inverse Fourier transform is given by f of x equal to 1 by 2 pi integral minus infinity to infinity f of u e power minus iux du. So it gives us f of x is equal to 1 by 2 pi integral minus infinity to infinity. We have the result minus 4 by u cube into u cos u minus sin u into e power minus iux into du. We require the result only like x cos x minus sin x divided by x cube. Therefore, so let us retain this only this term. We eliminate this by setting the x value is 0. So we put x is 0. So therefore f of 0 is equal to 1 by 2 pi integral minus infinity to infinity, and you minus 4 by u cube u cos u minus sin u, and exponential become 1 when you substitute x is 0 du. So what is f of 0? We have the function f of x is equal to 1 minus x square for modulus of x less than or equal to 1. So here f of 0 is 1. So substituting that we get 1 is equal to, here 2 gets cancelled. I'll take minus 2 by pi out, minus 2 out, divide by pi is there. And if you take u cos u, when you replace u cos u as minus u, we get minus u cos u, and sin u we get sin u, and divide by u cube becomes minus u cube. So just replacing u to minus u, we get the same function. Therefore this is even function. You can write this as 2 times 0 to infinity u cos u minus sin u divided by u cube du. Then just we cross multiply, okay, and we replace u as x, we get that integral 0 to infinity x cos x minus sin x divided by x cube dx as minus pi by 4. This is our required result.